So since we know what the equilibrium concentration is for ammonia, and we've created from the ICE table this equilibrium expression, we can actually use this relationship to solve for X. So if you recall, the purpose of this question, or what the question actually wants us to solve for, is the equilibrium concentration of nitrogen and of hydrogen. So essentially, when you solve for X and then plug X into these expressions for the ones we want, we get that value. So when we're trying to determine equilibrium values for ammonia, we have that expression. So I should change my color, you're not going to be able to see that. So 2.0 moles per liter minus 2x is equal to 1 mole per liter. So essentially, if we were to rearrange this and solve for x, we would get a value of 0.5 moles per liter. Right? So you just take your expression, you rearrange. It's like simple algebraic rearrangement here. Right? So you'd want to bring everything that's not an x to the other side. And then, of course, you would divide by the factor because we want x by itself. We don't want the -2 there. So you divide both sides by -2 to get your x. So now that we have x, we can essentially plug x into this. So because we know x is 0.5 moles per liter, nitrogen is x. So that means the nitrogen equilibrium concentration is 0.5 moles per liter. And because hydrogen's equilibrium concentration was 3x, we just simply plug in our x, which is 0.5. So 3 times 0.5 is 1.5 moles per liter. So at this stage right now, this first portion of equilibrium, you will always know the value of one substance at equilibrium. So whether that's from, they may give you a graph, right? So from the graph, you can determine the equilibrium value, or just like they did in this question, they'll give you the amount of moles, or you'll have the concentration. But basically, whichever one you're given, you have to set up this table, plug into rearrange and solve for x. And really, once you have x, you can solve for any item at equilibrium. So just to recap, where are we getting this C from? So your reactants are always a negative change. Your products are always a positive change. You have an x value for an unknown that we're not sure what it is, but we have to factor in the mole ratios because the change in concentration is not going to be the same for all the components because they have different factors, right? The mole ratios. There we go. So there's the start of our equilibrium.